Okay, so let's look at problem number 1 in the homework. We have a Lewis structure to draw from this chemical formula. So we count our valence electrons first, of course. 5 electrons for a nitrogen, 7 electrons for a chlorine, there's 2 of them, and then 7 electrons for fluorine. So our total electron count, uke, is going to be the 7 3 times over to give us 21 plus a 6. So total electron count is 26 electrons. We are going to choose a central atom for the molecule, and comparing nitrogen to chlorine to fluorine, nitrogen needs 3 electrons to complete its shell. Chlorine and fluorine atoms only need 1 from their position. So our central atom is going to be nitrogen, and we'll add the chlorine and the fluorine atoms round about to our structure, and then connect them through a chemical bond to that central atom. And that uses up 2 electrons at a time, so it takes us down to just 20 electrons. We'll use the remaining electrons to complete shells, so octets for the chlorine atoms, with 3 lone pairs, and octets for the fluorine, and that uses up 18 electrons. It leaves us with 2 electrons, so with nowhere else for those electrons to go, the electrons go on to the central atom as a lone pair. And it gives us completed octets for all atoms in the structure. Now the question doesn't ask for it, but just to look terribly clever, let's think about the shape of the molecule as well. We have the central atom with 1, 2, 3 chemical bonds, and also a lone pair of electrons. That's 4 groups of electrons. So the electrons initially take up a tetrahedral stance, but one of those is just a lone pair. So just a lone pair of electrons at the top of the structure, pushing down and repelling on the bonding pairs. So we have what we refer to as a truncated tetrahedral structure. Sometimes known, of course, as trigonal pyramidal, and with a bond angle of 107 degrees. Don't worry, remember the question was only asking for the Lewis structure. Question 2. Another Lewis structure problem. This time it will be asking about shape and bond angles at the end. Now let's start with our valence electron count again. And for a carbon atom we have 4. For an oxygen atom we get 6. And again for fluorine we get 7, but twice over because of the chemical formula. So our total electron count for the structure this time is 24 electrons. We're going to choose a central atom, and for our central atom we'll choose the carbon because it needs more electrons to complete its octet. It needs 4 after all, while oxygen only needs 2, and fluorine atoms only need 1 to make the octet. We'll draw the other atoms round about, so we have an oxygen atom and we have 2 fluorine atoms, and we'll connect them through a chemical bond each time. Takes our electron count down to 18 electrons remaining, and then we'll use those electrons to complete the octets of those outer atoms. Our little lone pairs as the electrons fill the individual orbitals as lone pairs. So that uses all of our remaining electrons. But we're still not happy because the carbon still doesn't see an octet, so it's still not in a stable relationship. So we'll use a pair of electrons from the oxygen to make a carbon to oxygen double bond. And we choose oxygen rather than fluorine because oxygen needs more electrons to complete its shell compared to fluorine. So oxygen should be capable of forming more chemical bonds. So there's our final Lewis structure. 2 bonding pairs and 2 lone pairs for the oxygen, and 4 bonding pairs for the carbon. And as we look at the shape of the molecule, we're counting the number of electron sets, number of bonds, so 1, 2, 3 bonds. Remember, the double bond is only counted once. With 3 chemical bonds, the best spatial arrangement. So let's look at the third problem in the homework. This hydrogen sulfide molecule, but it has a formal charge of +1. Again, for our electron count, 1 electron for each hydrogen, but there's 3 of them. The number of electrons from the sulfur atom itself, which should be 6. But then we've also got the charge to take into account. This time it's actually positively charged, which is telling us this combination of atoms is actually coming up 1 electron short from what we'd normally expect. So it's one of these rare situations where we actually take away an electron from our count. So our total electron count is actually going to be 8 electrons. Remember, when you're counting valence electrons for your structure, you're normally going to see an even number. If there's an odd number, then you've miscalculated in some way. So 8 electrons for the structure. Hydrogen to sulfur, we'll choose sulfur as a central atom. And we connect up those hydrogens, those 3 hydrogens, to the central atom through a chemical bond. That takes 2 electrons at a time, so it takes us down to 2 electrons remaining. And with the hydrogen atoms just needing duets, no lone pairs on hydrogen atoms, of course. The last pair of electrons goes on the sulfur. And that completes the octet for the sulfur atom. So in terms of shape, we have 1, 2, 3, 4 sets of electrons, but one of them is just a lone pair. So as we saw before, it's an example of a truncated tetrahedral structure. Sometimes known, of course, as trigonal pyramidal. Either term is fine, and the bond angle each time between each pair of atoms to the sulfur atom is going to be 107 degrees. Now the formal charge, of course, to work out formal charge for any atom, we take its periodic table count and compare it to the number of electrons it owns in the Lewis structure. So for hydrogen, from its position in the periodic table, hydrogen should control 1 electron. And we'll look at the environment in the Lewis structure. It sees the electrons in that chemical bond, but one of those electrons belongs to the sulfur. These are electrons which are being shared. So 1 from 2, so the hydrogen atoms each time are electrically neutral. For the sulfur atom, from the periodic table, the 6th element in the 3rd row of the periodic table, it should be 6 electrons. But how many does it actually control? Well, 1 of the 2 electrons in each bond, 1, 2, 3, and then the lone pair, 4, 5, so it only controls 5 of the 8 electrons around it, which gives it a formal charge of +1. So there's our formal charges, just the formal charge for the sulfur atom. And again, that ties in with the formal charge of the entire molecule. Individual charges in your molecule should match and tie in with the overall charge of the Lewis structure.